Okay, now the next one up is going to be what's known as rational numbers. Typically, when somebody's talking about rational numbers, they're almost always talking about fractions, but you're going to see that all of these numbers down here can be made to look like a fraction. All of them can. Okay, and I'll show you what I mean here in a moment. Right now, I'm going to put a Q. Q is not R. I know. Q is, the reason I'm using Q is because I can't use an R because you'll see I use it higher up. Okay, so let's go ahead, and that's going to include all of your fractions like 1/2 or -1/2. And those are going to be your rational numbers. Okay, but remember, all of these numbers below, all of your naturals, your whole numbers, which is 0 and all of those naturals, and all of your integers, which include your -1, -2, -3, okay, on forever that way. Okay, so there are your, okay, here's your definition of rational numbers. A rational number is any number that can, I did not say is, but it can be written as a ratio of two integers. A rational number is any number that can be written as a ratio of two integers. Rational numbers. Okay, so I told you I was going to show you how any integer can be made to look like a fraction, which is why all integers would also be considered to be rational numbers. So here we go. Let's look at an integer. Let's look at the number 3. How would I make 3 look like a fraction? Well, all fractions are also division problems. So what I would need to do is I'd need to make it look like a division problem. Now, what can I divide 3 by and it still be 3? I'll tell you, it's a magic number. And that magic number is a rational, it is rational, a natural number 1. So as you know, 3 divided by 1 is indeed equal to 3. I can do that with any number. I can go -7. -7 divided by 1 is still -7. So as you can see, any integer, even 0, 0 divided by 1, I cannot divide by 0, but I can divide 0 by 1. 0 divided by 1 is still 0, because anything divided by 1 is equal to itself. So as you can see, all of my integers can be written to look like a fraction. Therefore, all integers are also rational. So that's one side of all this. On the other side, you're going to have your, okay, and then finally, if you're not rational, if you're not one of these, okay, if you're not one of these, then you are irrational. And that's where the I comes from that I wanted to use for integers, but I could not. So these are going to be irrational. All right. And irrational just means that you cannot write it as a ratio of two integers. Okay, so here is the definition of an irrational number. If you look it up, you'll oftentimes see irrational number, not a rational number. It just means it's not rational. Well, we need something a little better than that. A very specific definition is a number with a non-terminating, non-repeating decimal. What that means is non-terminating is that that decimal goes on forever. Like 0.7832965, on and on and on and on forever. It just never has an end. Obviously, you can't write an infinite number of numbers on top of a fraction. You just can't do it. You can't write infinity. That's why it cannot be written as a ratio of two integers, and which is the other definition. Cannot be written as a ratio of two integers. Therefore, it is not rational. Now, some numbers, they repeat the decimal does. So 2/3 would be like 0.6666666. So those sixes, even though they go on forever, they're non-terminating. They do repeat. So 2/3 can be written as a ratio of two integers. So if the decimal goes on forever and it never repeats, then it is an irrational number. So the ones that you're going to see where the decimal goes on and forever and never repeats would be the square root of any imperfect square. Square root of 2, square root of 5. Whoops, that did not work out. Let me go ahead and try this here. Let's see. Square root of 5. Square root of 3. Now, of course, the square root of 4 would be 2, so that would be a natural number. The square root of 9 would be 3. That would be a natural number. Square root of 16 would be 4, and so on. But all the other ones that are square roots, you put that into a calculator, into a computer, and those decimals will keep going as big as the screen will let it, but they do go on forever and they never repeat. And then, of course, there's the most famous irrational number of all, and that is pi. Now, what does it mean by irrational? It means you cannot write it as a ratio of two integers. You cannot make it look like a fraction because the thing goes on forever. So if you put all of these together, all of your rational numbers, which are all of these, and all of your irrational numbers, which are all of these, and together they make the real number system. I don't know if that's probably the best color. Let me pick a different color for that. Let me go, I don't know. We'll go, that's a weird color. Yeah, let's go with this. Okay. There we go. Weird purple. That's going to be your real number system. So the R includes all of your rational and all of your irrational, and that is the real number system.